All right, everybody, we're going to review some factoring skills from Algebra 1 and then review it again in Algebra 2 in Chapter 4. These factoring skills have to be really solidified before moving into Chapter 8. So let's say that we have a quadratic trinomial, quadratic and then trinomial, and our directions simply say to factor, not to solve, just to factor. So the first thing we're going to look at, and on this problem it does have a GCF of 6. If we take 6 out of everything, we have n squared plus 7n minus 8. At this point, it would be a good idea for you to kind of ignore the original one so you're not tempted to use those numbers. Now, to factor this trinomial, there is a shortcut, and if you know it, that's fantastic. But if you don't really like taking those shortcuts, by the way, the shortcut only works because a is 1, then just follow through and do what comes naturally. So we identify A, B, and C, and then you make your ACB chart. Now you might say, hey, Miss Angela, you're going really fast here. If that's the case and you feel like I'm going too fast, please go back and review your 4 notes. So AC is 1 times -8, which is -8, and B is 7. You have to find two numbers, and those two numbers need to multiply to -8, for example, like 2 and -4, but those numbers need to add to 7, which 2 and -4 do not do. The correct numbers are a +8 with a -1. Then if you factor using a box, you go to a box. You put n squared on the top left, and you put -8 on the bottom right. You put your two numbers that you just came up with, 8 and -1, in the catty corner boxes with whatever variable was in the middle at the beginning, so n. Then you find your GCFs going down vertically and to the right horizontally. So in this case, n minus 1 and n plus 8. If you notice that you have any things that you need to tie up, like loose ends, you're like, I forget this particular step, stop in and please let me know, or go back again and review your 4 videos. So you bring your GCF of 6 and then your two binomials of n minus 1 and n plus 8. And that is how you factor the original polynomial given. The next problem I will do for people who use grouping. So number 8, people who do grouping, you are going to watch me do this in the complete way. Anybody who does the box method, go ahead and try on your own. So again, we need to look for a GCF, which one it does have a 4. Dividing out that 4, we have x squared plus 3x minus 10. Then we're going to get rid of, and again, I am going fast because this should be prior knowledge based on Algebra 1 and Chapter 4, Section 4. After you take your GCF out, you label A, you label B, and you label C. There is a shortcut that could be taken here, but if you don't know the shortcut or if shortcuts are too much, then please don't worry about them. AC is -10 and B is 3. I promise it's one of these numbers that I'm listing here, along with its paired number to get to -10. So it's either 1 with -10, which does not make +3. It could be 2 with -5 because that multiplies to -10. Well, that makes a -3. The good news is if you get the correct number but the wrong sign, the theory says you can change your signs and it will still work. So if I use a -2 and a +5, it will work. Now if you use grouping, you will now bring down that x squared, you will bring down your -10, but you will not bring down the plus 3x. You will bring over a -2x and a plus 5x. Then you will split this problem in half, and you will find your GCFs of each half. So this half, the GCF is x, and this half, the GCF is 5. Taking out an x of here and here will leave you with x minus 2. Taking out a 5 here and here will leave you again with x minus 2. As long as these two binomials match, you've done a good job, and that is your new GCF, x minus 2, and what's left over, x plus 5. Please don't forget your GCF from way up top of 4. Now, if you take the box method, you will end up at the same spot at the end. The next thing we need to do is number 15. We need to find our GCF. I will do this one for the people who use the box. The GCF on this is tempting to say 9, but it's not. The GCF is a 3. If we divide by 3, we will get 3r squared plus, just to double check because I don't have a calculator on me, 51 divided by 3. There we go, 17. 17r plus 10. So I'm going to cross this off so I don't use it again. The next thing we do is we identify A, B, and C. So A is 3, B is 17, and C is 10. Then I make my ACB chart, and A and C makes 30, B is 17. I promise you it is in this list with its pair that multiplies to 30. It's one of those. So is it 1 times 30 to make 17 when you add? No. Let's see, 30 divided by 2 is 15. There it is. There's your 17. The sign works. Now I'll move to the box. So inside the box, I'll put my 3r squared and my 10, and that comes from here and here. But instead of my 17, I need to split it up into my 2 and my 15, and each of those has an r. GCF down and down is a 1r plus a 5. GCF here and here is a 3r with a 2, and it's positive. Your final answer will be your GCF in the front, your two binomials, and the order that you can put like the vertical binomial and then the horizontal. It does not matter. There it is in factored form. I have one more to do for those of you who use grouping. So if you are grouping, again, you will look for a GCF no matter what. In this case, the GCF is 3. Sometimes the GCF is 1, and you therefore don't have to rewrite it. So 3k squared plus 1k minus 4. A is 3, B is 1, and C is negative 4. So when we go to our A, C, and B chart to get our numbers to work, A times C makes negative 12, and B is 1. I do promise it's one of these pairs to multiply to negative 12. For example, is it 1 times negative 12 and then add to 1? No, it is not. 2 times negative 6 to add to positive 1? No, it is not. 3 times negative 4? That will add to negative 1. So remember that rule. Change, change, change. I do think the hardest thing for students are to get these numbers here. Now, again, I'm doing this for people who use the method of grouping. So you write your A term and your C term, and then you replace your B term with your magic minus 3. And what variable do we have? K and positive 4. Then you split that in half. And over here, the GCF is a 3 and a K. And over here, the GCF works out to be a 4. It's kind of nice. And if you accidentally switch these, your GCFs will be a little bit different, but you'll end up with the same answer. So if I pull that out, I get 1k, take away 1. If I pull that, oh, look at that, I get 1k, take away 1. And those 1s in front of the k's are not really needed. All right, your new GCF is k minus 1. You see that double binomial there that we pulled out? And you're left with the 3k plus the 4. Don't forget your GCF at the very beginning of 3. And there it is in factored form. All right, so I've done 2 boxing, I've done 2 grouping. Now what we're going to do is talk about, and this is review from Algebra 1, what do we do if there are 4 terms? Maybe you actually skipped the first part of this video. You should probably slow down and pay attention now. Now, if you use the box method, when you have 4 terms, the first thing we do need to look for is a GCF. And in this problem, the GCF would have been, let's see, nothing but 1. So I'm not going to bother to rewrite it. Just go ahead and throw the first term in the top box, the last term in the last box, like we're used to, and then those two can go anywhere. All right, I'm going to do GCF, 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 GCF. All right, so GCF of 7 and 2 is 1, but they both have a squared. 42 and 12, let's see, that's going to be 6. 6 times 7, yes, so plus 6. GCF is 7 and 42, that's a 7, and they each have an A. And GCF at 2 and 12 is a 2, and they don't both have an A. So when we factor this, we get a squared plus 6 and 7a plus 2. Now, if you do boxing, if you do the box method, you have to check to make sure this is actually true. So what I'm going to do is check each arc one at a time. That would make 7a to the third. I just need to give these check marks. This would make 2a squared. This would make 42a, and this would make 12. So again, if you choose to do the box method, you need to go back and make sure that it actually works. If it doesn't, then it probably meant it was prime originally. Now this is where grouping maybe actually comes better because you just go and you split and you can see if it actually works. Oh dear, that's going to be large. I'm going to guess that my GCF in this whole entire thing is 7, but I'm going to need to pull up a calculator to see if that is in fact true. Right, here I go. So 392 divided by 7. And if you're wondering how I came up with 7, I saw the 14 and the 49. All right, 112 divided by 7. Yes. Okay, so 7 is my GCF. Had to double check on that. Those of you piling in, I am doing a video, so please keep your voices to a minimum. So the GCF in this case is a 7. They don't all have an M. So I'm going to grab my calculator back. Again, those of you coming in, I am recording a lesson, so just be patient. I have about 5 more minutes and I don't want to redo it. Dividing everything by 7, since I've already done it on my calculator, is 56 m to the third and plus 16 m squared minus 7m plus 2. And I divided all of these items by 7. All right, so whether you are grouping or whether you use the box method, you do have to find your GCF. Now for grouping people, you just split this in half now. The GCF of 56 and 16, let's see, does 56 divide by 16? Nope, so it's going to be an 8. So this is going to be an 8, and they both have m squared. And when we take an 8 and an m squared out, let's see, that's going to turn into 7m, and that's going to turn into a 2. And then the GCF here is going to be a negative because of this negative, and the only thing that works there is a 1. So dividing these items by -1 is going to give me 7m minus 2. Let's see. I did accidentally at the beginning, this should have been a minus 16, I apologize, which would have made this a minus 2, which now I'm okay because these match. That was my fault, I apologize. So my final answer is 8m squared minus 1 and 7m take away 2. Don't forget your GCF 7 from the beginning. And that was review of Algebra 1. Now we're going to go ahead and do 2 more and call it a day. So on 37, no matter what method you take, you need to find a GCF, which in this case will be 4. Dividing everything by 4 will give you 25. You can let them in, please. 25n squared, take away 4. Now I don't care if you use the boxing method or the grouping method. At this point, I do need you to be able to see the shortcut. This is called the difference of perfect squares. Now you learned this in Algebra 1, but it's also quickly forgotten. However, this is something that you need to be able to do moving on to any other math class, is noticing the difference of perfect squares. Difference meaning subtraction and perfect squares meaning, well, perfect squares. When that happens, bring down that GCF and draw me 2 parentheses to hold 2 binomials. The square roots go 1 as a plus and 1 as a minus. So the square root of 25n squared is 5 and n. And the square root of 4 is 2 and 2. That's how you factor the difference of perfect squares. Otherwise, you have probably a long ACB chart on your hands. So just go ahead and memorize. That's the one shortcut worth it. Now 46 is new. You have never seen these are perfect cubes. This is the only thing that you've never seen before, and this will come in handy when we get to chapter 5. I was going to get rid of all of them, but then I was like, I'll at least show it to you. All right, perfect cubes are new and it will not be tested in chapter 8, but it's worth going over quickly so when you get to chapter 5, you've seen it once. The only GCF here is a 1, so I'm not going to bother taking anything out. All right, again, this is new and here's how it works. You draw a parenthesis for a binomial and a parenthesis for a trinomial, and you take their cubed roots. Notice I'm slowing down in this particular problem. So the cube root of 8x to the third is a 2 and an x. Put that there. And the cube root of negative 27y3 is a negative 3 and a y. In order to get the second parenthesis, you take this guy and you square it. And you get a 4x squared. And then you take this guy and you square it. And you put it here, so that would be a 9y squared. And the last thing you do for this middle term is you multiply these two items together. So what are we going to get? A 6xy, and that goes here. Your signs will always follow this pattern. Same as the original, different than the original, and this last one is always a plus. So the pattern is same as the original, different than the original, and always a plus. And that's how you factor perfect cubes. Other than that, that's the only one you're going to do that's weird like that. Everything else should be hopefully review for you, but very necessary moving into chapter 8.